Hi everyone, I'm Damien Larocque. I'm here with Greg Rell and Winifred Camille, and today we're going to be presenting on blockchain plus digital signing. Next slide, please. So blockchain attempts to solve the problem of how we create a secure and decentralized ledger. More formal definition would be that it's a decentralized distributed digital ledger in which all committed transactions are stored in a chain of blocks, and the chain continuously grows when new blocks are appended. Side note that transactions are not necessarily, the transaction part is not necessarily limited to transactions. You can put any data that you want in a blockchain. Some of the key characteristics of blockchains is that they're decentralized, immutable, anonymous in the case of a public blockchain, and they're auditable because it keeps a history of all data added to the chain. Next slide, please. Really quick, the history of blockchain is that in 1991, Haber and Stornada outlined the blockchain structure in a paper. In 93, the proof of work consensus algorithm was invented to deter DOS attacks. 2004, Haber and Stornada lost the patent to blockchain, so it became public so anyone could use it. In 2008, Satoshi Nakamoto, who's an anonymous person or persons, published the Bitcoin white paper and added blockchain mining. 2009, we had the official launch of Bitcoin. 2012 was the launch of the proof of stake consensus algorithm. And in 2021, the cryptocurrency market cap hit $1 trillion, which obviously generated a lot of hype towards blockchain technology and cryptocurrency in general. Next slide, please. Some of the challenges with blockchain is that it has scalability issues, where the larger the ledger, the less secure the blockchain tends to be. If it's too small, then it can't store enough data. It's also expensive and resource intensive. Like, for example, with Bitcoin, it has a very high carbon footprint, and the power consumption is equivalent to what Ireland used an entire year. Verification of blockchain is slow, and branches can take place frequently.
All right, so for the longest, a blockchain has used proof of work to validate new blocks. This method used a huge amount of energy, which creates high levels of carbon emissions. For this main reason, the industry has been moving toward a different approach called proof of stake. So the way that proof of work authenticate a block is by having all the miners solve a cryptographic puzzle, and the miner that solved the puzzle first receive the mining rewards. So because of that, people would build larger and larger mining farms to be able to compete and collect the rewards, which leads to a huge consumption of energy. With proof of stake, instead of everyone competing, only one node is almost randomly selected to validate the block, which significantly reduces the amount of energy used. Another advancement is the introduction of smart contracts. Typically, in a blockchain, transactions data are recorded or stored in the blocks. A smart contract is a piece of code that performs an action depending on certain conditions. One of its convenience comes in the fact that it eliminates the need for a third party when it comes to a transaction between two parties. Let's take a look at the Kickstarter platform, where you have an idea but no funding to bring it to fruition. Such platform allows you to set a goal and a deadline. People pledge the project, and if the funding goal is reached by the deadline, the donor's credit cards are charged and you receive the fund. If the goal is not reached, the donors are not charged. With smart contracts, this process can be automated and there would be no need for the Kickstarter platform. Also, because smart contracts are stored in blocks, they cannot be tampered with after creation, which makes them trustworthy.
So how do multi-agent systems and blockchain go hand in hand? So multi-agent systems can be physical or software entities. Agents may or may not be trusted. Blockchain is one solution to enforce the trust problem in multi-agent systems. Communication is done via smart contract at the beginning of the ledger. Cooperation and coordination are both done through the ledger and ledger history. So figure 1 shows two agents that are signing a smart contract for a scope of work. Once signed, the contract exists and it's as the first block on the ledger. This provides a suitable platform to provide validity and accuracy of communication between two agents. Figure 2 shows a single scope of work being achieved by a collective of agents who sign the contract, and each of those individual roles are then encoded in the chain ledger. The ledger then represents the overall workflow for the common task, and it is immutable and unchangeable. The contract can only be changed if all signing agents agree and arrive at the proof of work or proof of stake consensus. The hash of the contract can be used as the address of the contract that is accessed by the agents, and the agents can use the instructions within the contract for their own execution. Therefore, a trustworthy agent system now exists. Let's take a look at a voting system using a multi-agent smart contract system. So this has 3 agents. The first one, Alice, sorts incoming ballots. Bob counts ballots, or he counts ballots for only candidate 1, and Eve counts votes for only candidate 2. Bob and Eve are considered untrustworthy agents. A smart contract exists between Bob and Eve to store 2 attributes of a candidate, the name and the gender. The ledger is based on the smart contract, and each agent sends its transaction to the ledger as it counts votes. Initially, the contract is signed by the agents and placed at the ledger, forming the first block. The agents act as outlined in the contract in their core functionality and place each vote on the ledger, keeping a tally of all the votes for each candidate. The ledger keeps the integrity of the contract and all votes tallied by each agent. So how this advances and improves society is that we now have automation in areas where an intermediary or a third party was once needed, and a layer of trust exists surrounding software agents where no human verification is also needed. That's our presentation, and we hope that you leave us questions in the comment section. Thank you.